Hello and welcome to the MachiningCloud CGTech Vericut webinar. I'm Charles Smith, Senior Technical Engineer. Joining me today from MachiningCloud is Pierre-Francois Tavard. He's Accounts Executive. Pierre-Francois will be answering your questions during and after the webinar. From CGTech Vericut, we have Jeff Vagley, Vericut Product Specialist, who will take over to show the Vericut part of this webinar. I'm sorry to say you'll be muted during this webinar. There is Q&A on here for you to use. As I said, Pierre will be working to answer questions throughout the presentation and after, along with myself and Jeff. We may not be able to answer all your questions or comments during this time. Any that are not answered will be answered after the webinar. Alternatively, you can email any questions or concerns you may have at a later date. What I'll be covering today is searching and navigating the app, tooling assemblies and feeds and speeds, and creating a job for export or import into Vericut. I'm just going to So Q&A is up here for anyone that needs to have a look at that and ask any questions. So just thought I'd let you know where that is if you wasn't sure. I'd like to start by showing you the home page and all its functions with a brief description of each function for those of you that are not familiar or have not used MachiningCloud before. I'll go into greater depth with some of these functions later on. First tab here is Browse Catalogs, where you can see this is all the companies that we carry for tooling. 20 are Buy Now, where you can purchase tools within the app, and 54 brands we have for tools and tooling data. Browse Products. This is rather than browse by brand, you can just browse by product, and then you can just hit any of these tabs, and that will take you to the next page, obviously, and you'll be able to find what you're looking for that way. Tool Advisor is where you can create a feature, and MachiningCloud will find the best tool for that feature. At present, we only support Kennametal and Whittier, but we are working on Tool Advisor across all brands. So you'll be able to create a feature and we'll find the best tool for you to machine that feature. Job Management. This is where you can create your tooling and work holding lists for different jobs that you are creating. I'll go into greater depth with this later on. So the tech videos and tutorials takes you through to YouTube, where there's a lot of information in there for you to be able to look up and find whatever you may need within MachiningCloud. Also, this webinar will be posted on there probably later on in the week. The search bar, this is always in cross-brand search. So whatever you type into here will be all of the products that we carry. Once in there, you can then search by brand afterwards, but I'll show you that function a bit later on. So you've got inch and metric here. That's obvious what that is. We can just switch between them as you want. We do support quite a few different languages throughout the globe. You can click on there and see if it does support the language you wish to have MachiningCloud in. This downloads shows when you're downloading anything and the progress of that download. Notifications is basically if any jobs that you've been sent you'll receive here, or messages from MachiningCloud. The cart is obvious what that is. Again, it's just anything that you want to purchase you can put into your cart. You can edit the cart from here as well, so you can take things off as most carts work. And then this is just your account details. I won't go into there because it's private stuff, but you can go into there and make changes to whatever you need. So home is obviously what that is. It takes you back to the home page each time. So job is the same as job management, which is down here. This is for you to add anything you would like to save and get. Oh, sorry. I'll start again. This is the same as job management. Apart from it makes it easier to access the jobs from rather than going back to the home page. You can do this when you're a bit more in depth into MachiningCloud. My workshop, this is for you to add anything you'd like to save that gets regularly used in your machine shop, to machines, to materials. Search is the same as browse products. Your tool advisor is the same. We've just got 2 tabs for that. If you have any tool assemblies in progress, that would be shown here. So you can have a look here and you can go to your current assembly. You can have a quick look at that, see what's going on there, and that can also be deleted from there as well. So you can delete that out and go back to the home page, then that tab disappears. Help. We've got Contact Us, Technical Videos and Tutorials, which is the same as over here, and just about MachiningCloud in general. We do have a guide here, which is quite helpful. It will, once you click on that, I won't show it now, but it will help you navigate a bit like what I'm doing now around the home page. Catalogs down here is just the MachiningCloud brands, and terms of use is just our terms of use. So there's a brief overview of our home page. What I'll do now is I'll show you how to create tooling assemblies with components from various brands, add them to a job and send them to the relevant persons. So I'm now going to create tooling for a job for Jeff, but to be used in Vericut. So obviously before you start that job, you're going to want to know some information about what the tools are going to do. So you're going to want to know what material it is, hole diameters and depths, internal, external radii, and obviously if you have a blueprint, drawing or model that you can use before selecting the tools, even better. But obviously I know what Jeff wants, so I will start today by showing you the tools and how I'm going to set them up, and then pass them over to Jeff to use in Vericut. So I'm going to search for a 25mm end mill. I'm going to go milling. We want a solid end mill. So one of the most important things to set up to start with is your workpiece material. So you can come in here, you can select the drop-down menu, and I know that stainless steel is what Jeff wants his part to be made from. So we can select that, apply the filter. Now that will give me all the tools that are available to be able to cut that material. Some of the tooling we have that we don't always have 3D models for, which is going to be quite important for Jeff in Vericut. So it's always good to come down here to miscellaneous and make sure that the 3D models are available. The filters here, are very good, will help you narrow down to what you want. So I know we're going to want a maximum depth of cut, or a minimum depth of cut rather, of 50mm. So we can type that in there, select that. So as you can see, we're starting to populate up here the properties that we need to create this job. You might want to know whether it needs a corner radius or not. So we can come down here, select a corner radius. I don't want a corner radius, so I'm going to select that one. And it's given us 2 selections here. I'm going to go with the cheapest one. So here we go. Here's the model. We can have a look at it in 3D just to show we've got all our information here. And we just click up here to create a new tool assembly. So we can add any items through here. For this, we're probably just going to want some sort of shrink fit holder. So we can just add an adaptive item. This will go through all of the brands and show any of the tooling that will connect correctly with the tool that I've selected. Again, we want to have a look, make sure 3D is available. And yes, it is available for all of those products, which is great. I'm going to have a look at the shank style just here, because I know that I'm going to want BT40. And then I'm going to go and check. I think I might know what brand I want. So you've got 6 from Vericut and 3 from Seiko. I'll go with Vericut. And like I say, I know I want a shrink fit holder, so I'm going to go with that top one there. Add to assembly. And what we can do is we can have a look at the part, at the tool and the full assembly, which is quite nice on there. Happy with that. So now I want to create a job to put this tool in so I can be able to send that over to Jeff. So if you go up here to add to, we can create a new job. So we can add it to this job and OK. So once that's done, we can go into here. We can go to current job. Let's change the name of that to make it a bit easier. Vericut. We want to have a workpiece material on here. This group. Up here to whatever may be. So let's just get metal on there. Group. And then that'll give us more options within here. So we want the M1 on there. You can OK that, and that will populate up here. You can add a machine in here as well if you like. I've got some machines already set up in there, so MC10, whatever you want to do in there is good. What we can do now is have a look at the tool list, and it will show that tool that I've already created and put in there. So we can now go back to our home page, and that's our first tool done and our job created. So we need some other tools for that job. We also need a 20mm end mill. Again, we want a solid. So it's already populated the workpiece material in here, which is great. And also that we want a 20mm end mill. Again, it's worth checking that the 3D available is there. And I also know that we've got a depth of cut of 42. I'm going to have a change of the brand here. Let's go with this car. And then we're going to go, let's go with this. It's a roughing and finishing end mill. Again, you can have a look at any of the dimensions, and we can also check the 3D model, which is a nice rendered 3D model as well. So we can create a new tool assembly there. Again, we just want to add an adaptive item. "3D available." Yep. And then shank style again. And we want to keep the status quo there, so we want BT40. And then we want the shorter of the two, which is this one. Add to tool assembly. So we can see in 3D viewer here. So we've got the stick out. It's probably a little bit too much. We might want to move that in a bit so we can edit dimensions up here. And we just want to move that in. It's 10, let's say, see what that looks like. So if once I click OK here, if you just have to concentrate on this area here of the tool, you should see that move. There we go, nice bit in a bit further, which is great. So from there we can add to. We can add to current job. So we'll add to that. Just to double check that it's the Vericut job that I want to add that to. Okay, that. And then that's been added. What we can then do now is move on to our third tool, which is a 14mm and now. Again, we're going to go with solid. And what we'll do first is we'll go by brand. So if I come up here and I can select, say, Kennametal. Also, you can change that up here as well. So as you can see, we're already in Kennametal. So that's fine. Material's already correct. And you can have a look at maximum depth of cut. We're going to want 50mm in there. And it brings up 3. And we'll just pick that top one there. So again, we can see that tool. You can see it's a nice rendered model. We can create a new tool assembly. Add an adaptive item. As you can see, we're still in Kennametal, so it's only Kennametal holders that come up. And we can have a look at the back end because we know what we want there, and it's PT40. And then we want the shrink fit adapter to that one. We can add that to the assembly. We can see we've got the 3D model there. And we can add that to the job, current job. Okay. Also, at this point, you can have a look and check feeds and speeds and things like that and make sure that they're correct. So we've got the right material in here, and this is Kennametal's recommended feeds and speeds for this part in that material with side milling. So you have all your information in here, which that will also transfer over to Jeff in Vericut. So you should have all that information as well. Remember whether I added it to the job or not. Let me just OK that again, and then we can go and check that at the end. Actually, we'll check it now. Ready to do current job. See the tool list. So yeah, I added that tool twice. It's very easy to take out. Click on the box and delete. There we go. And then there's those 3 tools that we've done so far. Go back to the home page. We're going to do tool number 4. This is the last end mill. And then we're going to do a indexable drill after this. So 12 mil end mill. We go with the solid at 12 mil. So we've got the workpiece material is correct. We'll go and check that it's all 3D models are available. This one needs less depth of cut. We're going to go for 25 mil. Plenty of those. And we're going to want a corner radius in this tool. Half a mil. Let's go with this one here. Create new assembly. Add an adaptive item. 3D available. Yes. I'm going to go with shank style again. Because we want BT40. And we're going to go with Lindex Nikon and the shorter of the 2 there. Add to assembly. Show a 3D. So if you ever create an assembly and it doesn't show what you want, sometimes the connection codes aren't quite correct, the tool may not be inside the holder or anything like that, you can always report a problem with us. That's just here. Select that, enter a brief description of the issue and send, and we'll get that and we'll get onto that as soon as we can. Alternatively, there is other ways of doing that. You can just email us directly or in help as well. So there's a few different ways you can do that. This is quite nice because it will report the problem and it will show us as the 3D model and what the issue is. And our support team will get onto that as soon as possible. So we can add that to our current job. Okay. And then we can move on to the last of our 5 tools. Here, making drilling indexable. So again, the material is correct. You can check because we want a 3D model, which there is. Let's go with a brand, go with Whittier. And let's go with a cut-in diameter 15.088. And let's go with this one here. Okay, so there's a bit more to this now because we've got 2 inserts we need to add to the assembly and then obviously a holder as well. So we can create a new assembly. And we're going to go with the outside insert first. Ready available. Yes. Workpiece material. Let's pop that in there. And then we're going to go with this one here. This one here. We're going to add that to the assembly. Then we can add the inside insert. 3D available. Yes. Piece material. It's important. Again, this V36 one we'll choose. Add that to the assembly. And then we need to add the adaptive item. Back end, 40. And we're going to want an end mill adapter. This one here. That's assembly. So this is all populated now, so let's take a look at our 3D viewer. And there we go. Both inserts are mounted. The insert drill is mounted to the holder. And so we've got a full assembly there. Add that to the current job. What we'll do is we can go and take a look at that in job management, so we can go and have a look. So we've got all the information that we may need in there. Got the tool list, tool 1, 2, 3, 4, 5, everything we want. So just to keep the status quo, what I will do is go back to jobs management, and I'm going to unselect that Vericut one because I've already set up one to Jeff that should be perfect. The other one may not have been because I've been going backwards and forwards a little bit. I know that this one's good, so I can go into here and select that job. Once I'm in here, I can then send copy to, and then we can email CGTech, send a little message if we like. Here is your Bob. And then we can send that. That will go across. Jeff will receive that his end, which is actually my time to sign off. Where I'm going to pass over to Jeff, who will show you how to use the tools that I've created for him in Vericut and to produce a program and ultimately produce the job that's required. So Jeff, if you'd like to take the screen and show it from your end.
Thanks, Charles. And thanks everybody for taking some time out of your busy schedules to join us today. So picking up where Charles left off, let me share my screen here. So as you saw, Charles brought over or sent me a job here. So what the nice thing is that happens is it sends an email and it notifies me that there's a job available. So if I go take a look in MachiningCloud, you'll notice here's that job that he sent me. I can then go ahead and export that. I can take a look at it as well with the 5 tools, but I think you guys all saw that. I'm going to output a file, and you'll notice here it's generating a file for me to import into Vericut. So while that's doing its work, so let me bring up Vericut here. So as Charles mentioned, my name is Jeff Vagley. I am a product specialist here at CGTech, who are the developers of your Vericut simulation software. In case anyone's not familiar with our product, let me just give you a real quick review of what Vericut is. It's a verification software that's used for simulating your NC program before you take it down to your shop floor. We're the industry standard when it comes to this simulation. We're going to look at a couple of things in Vericut, as there's a variety of items that need to be brought in whenever you do a simulation, from the parameters of the machine to the offsets that are needed to the tools that Charles just created. So we're just going to focus primarily on two main items today: the tooling that we're going to bring into Vericut, and then we're also going to talk about possible optimization and how that ties into what Charles was showing. So the first thing I'm going to do, I'm going to come into Vericut's tool manager, and I'm going to import that file that I just generated. So here is that zip file, and you'll notice I've got 5 files listed there. I'm going to grab all of them, and as Charles mentioned, we are cutting 420 stainless, so I'm going to select that from our material catalog, and I'm going to import these tools. Now, the key benefits of being able to take tooling out of MachiningCloud and bringing that into Vericut are twofold. The first is I get the geometry. So just as you saw as Charles is going through and building these different tools, I have those that exact geometry that was brought over here into our software that we can then utilize in our simulation. And there's that final drill, that indexable drill. Now, there's 2 types of tools that you can bring in. One would be this simplified spun representation. So you'll notice here you don't see the 2 specific inserts. There is also capability where you can bring in that detailed model. In this case, I just figured this was good enough to show you what I'm looking for. The other aspect that I want to talk about and Charles mentioned it when he went into, I think, the 3rd tool here. So we have, in addition to, for example, tool 3, I've got the various components you can see that he built, and I also have a stock material record that's here. So what this is the cutting limits and optimization settings that Charles showed you on that page with feeds and speeds. We're able to read that into Vericut if that data is available. And then we can use that in optimization and doing other various checks in our Vericut software. If by chance a tool does not have that information, we can come in here and simply pick the default data that goes along with that, and then we can set that for each of those tools. Okay, so I'm going to just go ahead and save this and pick a name here, and I'm going to cheat and use a name that's already there and take off that extension, and we'll save that. So when I come in here now, I have my tools loaded, and if I zoom in, you'll see we've got a simple part that we're going to machine. We're going to rough this out, profile some of these walls, and then drill a couple holes at the very end. And I'm going to slow this down just so everyone can see this, but we can now use those tools exactly as is in that simulation. And you can see here, this will be done in just a moment, drilling those couple of holes, milling that slot. And we've been able to use that data that Charles built as far as the tooling goes and use that in our simulation here. So that's fantastic from the first aspect, that we can make sure we've got accurate tool geometry that's in here for the cutter size, as well as clearance or anything if you get into some very tight areas on fixtures and whatnot, or whatever the design of the part may be. I'm going to reset this though, and now I'm going to show you that second aspect of the tooling that we brought in, where we can utilize those feeds and speeds and cutting limits in our optimization software. So I'm going to turn on a couple of items here. I'm going to turn on a graph. And if we go in and optimize this program now, I'm going to rerun this simulation. I'll speed this up, and you'll notice this graph is going by here on the right. But what we are able to do is we take the existing program and we verify the feeds and speeds that are in it, and then we also look at what the recommended cutting limits are. In this case, we focused on chip thickness with the tool. So before we get into the details of that, I want to point out, so when it's done running, I've got a graph or a savings calculator here, and you'll notice up here, if we focus our attention on the top white field, there's first of all a bar that shows the various tools. Each color represents those 5 different tools that were used. And then the lower bar represents the time on each of those tools used after we ran our optimization. So you'll notice specifically on these very first tools, Tool 1 and Tool 2, there was quite a bit of savings there. And you'll notice there's just a little bit under 40% time savings overall on that whole project or that whole program. Now, if we turn our attention over here to the right side where that graph is, let me go into one of these areas here. So here, this graph represents one pass of that tool, the specific tool being used here, Tool 1, on the first roughing cut. So the darker green shows the feeds and speeds, or in this case, the chip thickness that was used. And this red line represents the recommended chip thickness for that tool to be used. So this light green, think of it as money being saved. It's reducing your program, optimizing the tool path. So why would we want to do that? Well, you get a variety of benefits from that. One, you get a faster program. You'll get a constant chip thickness, which will extend the tool life, and you'll also get a better finish on the part when you're cutting that. So those are just some of the quick benefits you can see from utilizing those cutting limits, those feeds and speeds in our Vericut simulation software. So, and then this is on, and then when we ran our force optimization, you'll see we even got further benefits by reducing that programming time as well. So with that, I just want to close. Oh, and one other item to show you. So what this does, before I forget, when we ran that simulation, we also generated a program. So we took the existing program that was provided from our CAM software. That's the one you see on the right here. And then we have an optimized program that's marked here on the top, says optimization by Vericut version, and then it shows the date. And if we scroll down, you'll notice all it does is we're changing the feed rates, or we'll take lines and we'll break them up and enter in different feed rates so we can achieve that optimized chip thickness that we really wanted to get. We're not changing any kind of motion whatsoever. We simply leave the motion alone, and we just simply adjust the feed rate that's in there. So with that, just to kind of recap, we were able to bring in the tool geometry that Charles had built. We also utilized those feeds and speeds in our optimization software, Force.
From myself, Pierre, and Jeff, and the rest of the MachiningCloud CGTech Vericut teams, we'd like to thank you for joining our webinar today and taking the time. We'd also like to thank you for your continued support of MachiningCloud and CGTech Vericut. Thank you very much, and goodbye.